This is in continuation to the chapter that we did before the exam. That was chapter 4. We had done 2 parts before the exam. This is the third part. In this third part, the first thing that you're going to see is about isotopes. Isotopes are atoms of the same element having same atomic number but different mass number. Like say for example, if this is an atom which is represented, usually the symbol is there of the atom and the number above is the mass number and the number below is the atomic number. Mass number and atomic number. 2 numbers are here. Okay. It says isotopes are atoms of the same element. Okay. Like say for example, isotopes of hydrogen. There are 3 isotopes of hydrogen. Okay. Having the same atomic number but having different mass number. The atomic number, that's the number which is below, this will be same for all the atoms, but their mass numbers will be different. So you can say that they have the same atomic number but different mass number. That's the definition for isotope. Or you can say isotopes are atoms of the same element having the same number of protons and electrons, but they have different number of neutrons. Okay. Why different number of neutrons? That is why the mass number differs in all these isotopes. Their atomic number is same, but their mass numbers are different because the number of neutrons are different. Their number of electrons and protons are same. I have given you examples of few isotopes here. First example are isotopes of hydrogen. There are 3 isotopes of hydrogen. The element is hydrogen, but it has 3 different isotopes. The first isotope of hydrogen is called protium. The second one is deuterium. And the third one is tritium. These are the 3 names given for the isotopes of hydrogen. The first isotope, that is called protium, is represented like this. H is hydrogen, 1 is the mass number, 1 is the atomic number. Second one is deuterium. Again, it's an atom of hydrogen having mass number 2. Look at the difference. This has mass number 1, this is mass number 2. Here the atomic number is 1, here also atomic number is 1. Atomic number is same. The mass number has changed. The third isotope is called tritium. This is also an atom of hydrogen having mass number 3, atomic number is 1. Compare all the 3. Atomic number is 1 here, 1, 1. Atomic number remains the same. The mass numbers are different. For the first one it's 1, second one is 2, and the third one is 3. Okay. Now, what does this atomic number represent? Atomic number represents number of protons or electrons. So for the first one, the number of protons and electrons are same. That is the atomic number, that's 1. Proton is 1, electron is 1. And the difference between the mass number and the atomic number will give you the number of neutrons. So 1 minus 1 will give you the number of neutrons. Neutrons are 0. Okay. After subtracting these 2, you got neutrons are 0. So look at the structure that I have drawn. This is the nucleus. Inside the nucleus you have protons and neutrons. So I have written there is 1 proton and 0 neutrons. And this is the first orbit. First orbit contains the electrons. The number of electrons are 1. So I put 1 electron there. So it has 1 proton, 1 electron and no neutrons. 0 neutrons. That's for protium. Next one is deuterium. This is what is represented for deuterium. Hydrogen atom with mass number 2, atomic number 1. Atomic number represents protons and electrons. Proton is 1. Electron is also 1, same. The difference between these 2 numbers will give you the neutrons. So the neutrons are 2 minus 1, that's 1. So the second one has 1 neutron. First one had no neutrons. The second one has 1 neutron. These numbers are same. Proton 1, electron 1, here also proton 1, electron 1. Whereas the number of neutrons are different. So the structure, this is the nucleus. It has 1 proton and 1 neutron. And the first orbit has electrons, number of electrons are 1, so 1 electron is here. The third isotope is tritium, represented with atom of hydrogen having mass number 3, atomic number 1. Atomic number is 1, therefore protons are 1, electrons are also 1, that's according to this. And the difference between these two should give you the neutrons. So 3 minus 1 gives you neutrons, which are 2. So now compare all three of them. Protons, electrons are same in all. It's only the neutrons which are different. First one has no neutrons, second one has 1 neutron, third one has 2 neutrons. The structure for the third one is, this is the nucleus. It has 1 proton and 2 neutrons inside the nucleus. And this is the first orbit which has the electrons. Electrons are 1. So 1. Everything else is same in all these structures except for the neutrons. That's what is different. Okay. Because the neutron numbers are different, their mass numbers change. That's why isotopes are atoms of the same element having same atomic number. Atomic numbers are same, means they have protons and electrons which are same, and they have different mass numbers. Mass numbers are different because the number of neutrons are different. So that's about isotopes. There's one second example which I have given for isotope. That's isotopes of chlorine. Again, chlorine has 2 isotopes. Look at the isotopes of chlorine. First one, chlorine atom with mass number 35, atomic number 17. Which means this has 17 protons, 17 electrons, and the difference between them will give you the neutrons. So this one has protons 17, electrons 17, and neutrons is the difference between these two, that will give you 18. And the second one, this is the second isotope of chlorine. Atom of chlorine with mass number 37, atomic number 17. Atomic number is 17 means protons are 17, electrons are 17, and neutrons is the difference between these two. 37 minus 17 will give you a 20. Look at the difference in both. Protons, electrons are same in both. It's only the neutrons which are different. So these two are isotopes of chlorine. They have same atomic number but different mass number. That could be the definition for isotope, or you can write they have the same number of protons or electrons but they have different number of neutrons. That's about isotopes. Next, about duplet rule. Duplet means 2. Okay. So this is a rule about having 2 electrons in the first orbit. It says for an atom to achieve stable electronic configuration, okay, it must have 2 electrons in the first shell. That is, if the first shell is the outermost shell. It has only one shell, one orbit, and that is the outermost orbit. It doesn't have a second shell, third shell. Okay. There is a nucleus and it has only one orbit or one shell. In that case, the number of electrons that it can be filled in the orbit are a maximum of 2 electrons. So, for an atom to achieve stable electronic configuration, it must have 2 electrons in the first shell, which will be the outermost shell, like that of noble gas helium. I have shown you helium here. Helium with mass number 4, atomic number 2. Atomic number is 2 means it has 2 electrons. Therefore, its electronic configuration is, it has only 2 electrons. Those 2 electrons will be in the first shell, that's K shell, that's 2. It's fully filled. This is the first orbit. The maximum number of electrons that it can have is 2. Now there are few atoms which may have more than one shell, but they need to achieve a stable electronic configuration. Means they should be fully filled like this. Okay. That is attaining stable electronic configuration. Okay. How do they achieve that? Is, I have given you one more example here. Look at this. This is lithium, Li. Lithium having mass number 7, atomic number is 3. Atomic number is 3 means it has 3 electrons. Electrons are 3. Okay. There are 3 electrons here. and these 3 electrons have to be arranged according to their orbits. So electronic configuration for this, the first shell can have a maximum of 2 electrons, that's 2, and it has 3 electrons, 2 is here, so the remaining 1 is in the next shell, the second shell 1. Now if this needs to attain a stable electronic configuration, this is not completely filled. If it has to be completely filled, then it should be having 2 electrons in the first orbit, and if this is the outermost orbit, it should have 8, or it should not have a second orbit at all. Okay. Either this has to be filled with 8 electrons altogether to be attaining stable electronic configuration, or this 1 electron should not be there. So this one can give away this 1 electron. So if this 1 electron is given away, its electronic configuration becomes K shell having 2. This is not there, which means it has attained stable electronic configuration like the atom of helium. One more example. This is beryllium having mass number 9, atomic number 4. Atomic number 4 means electrons are 4. Now you have to arrange this according to their orbits. So the electronic configuration is, first shell has 2 electrons, it's K shell having 2 electrons, the remaining 2 electrons go to L shell. But again, this is not fully filled. If it has to be fully filled, this has to be 2 and this has to be 8, or this has to be 2 and there should be nothing here, which means there is no second orbit at all. So what beryllium does is it gives away the 2 electrons. If these 2 electrons are given away, it has a K shell which is fully filled. It attains the same electronic configuration. So it has attained stable electronic configuration. Okay. So to attain stable electronic configuration for any atom, it either has to give away the electrons or it receives electrons from something else. Okay. In the next example, I'll show you how it is done. So that's about duplet rule. Duplet rule is about only the first shell being fully occupied. Okay. Next. Is about octet rule. Octet means 8. This is not to do with the first shell. First shell can contain a maximum of 2 electrons. That's the maximum. But this is about 8. So the second orbit, if it is the outermost orbit, the second orbit, then it should be filled with 8 electrons. If it is the third orbit, if that is the outermost orbit, it should be filled with 8 electrons, and so on. So for an atom to achieve stable electronic configuration, it must have 8 electrons in its outermost shell, like that of noble gas other than helium. I am giving you examples of noble gases other than helium. The first one is neon, having mass number 20, atomic number 10. Atomic number is 10, means number of electrons are 10. Arrange this 10 according to their orbits. Electronic configuration is first orbit has 2, second orbit has 8, and then that's 10. So this is fully filled. First orbit is fully filled. This is the outermost orbit. Outermost orbit should have a maximum of 8 electrons, so this is also filled. That's why it's called a noble gas. The next example is argon, having mass number 40, atomic number 18. Atomic number is 18, means number of electrons are 18. Arrange these electrons. Electronic configuration is K shell has 2, L shell has 8, M has 8. This is the outermost orbit, and if it is the outermost orbit, the maximum number of electrons that you can fill is 8, and it is fully filled. Okay. So this is filled, this is filled, this is filled. So everything is filled, which means it is a noble gas. Okay. So both of them are noble gases other than helium, where if you see, other than the K shell, the outermost shell should be filled with 8 electrons. That's octet rule. Okay. Coming to this example, this is sodium, Na, having mass number 23, atomic number 11. Atomic number is 11, means number of electrons are 11. Arrange these electrons according to their orbit. Electronic configuration is K has 2, L has 8, M has 1, and then that gives you the 11. Now look at this. is the outermost shell and it has 1 electron. If it is the outermost shell and if it has to be fully filled, then it should have 8 electrons, but it has only 1 electron. So either it should give away that 1 electron to attain electronic stability, or it should receive 7 more electrons to be fully filled. So the easier way is giving away the 1 electron instead of getting 7 electrons from something else. So what sodium does is it gives away this 1 electron. Electrons are negatively charged. So if it gives away 1 electron, 1 negative charge it gave away, therefore it becomes positively charged. So this 1 electron is given away, so it attains electronic configuration 2, 8. This 1 electron is removed, 1 negative charge is removed, therefore this atom becomes positively charged. Okay. So Na becomes Na plus, I have written. Plus means 1 plus. Okay. 1 positive charge it gets. Why? Because it gave away 1 negative charge, 1 electron got removed. That's why it became 1 plus. Okay. So such things are called ions. In this case, Na, which was an atom, becomes Na plus an ion. Such ions are called cations. Okay. Positively charged ions are called cations. So sodium becomes Na plus, which is a sodium ion, which is a cation. Okay. Cations are positive ions. Look at the second example. Chlorine has mass number 35, atomic number 17. It has atomic number 17 means number of electrons are 17. Arrange this. Electronic configuration is K shell has 2, L has 8, M has 7. 2, 8, 7, if you add, you get 17. Now look at this. This is the outermost orbit. It's not completely filled. If it has to be completely filled, it will require 1 electron, or it has to give away 7 electrons. The easier way is it receives 1 electron. So that this becomes 8. So if it 8 by receiving 1 electron from something else, then this becomes fully filled, which means it has attained stable electronic configuration. Okay. So it got 1 electron. Electron again is a negative charge. So it got 1 negative charge. Because it got 1 negative charge, this whole atom becomes negatively charged. In this case, it gave away 1 electron, 1 negative charge was given, therefore this became positively charged. In this case, it received 1 negative charge, that's 1 electron, therefore this becomes negatively charged. So Cl atom becomes Cl minus because it received 1 electron. Therefore, negative ions, this is also an ion, this is a positive ion, this is a negative ion. These positive ions are called cations, negative ions are called anions. So anions are negative ions. So this is how you get positive and negative ions, either by giving away electrons or by receiving electrons. Once they become ions, cation or anion, now they have the ability to combine with each other. Okay. That example I'll show you in the next one. This is the formation of compounds and their chemical formula. How do you get the chemical formula? When you combine two different atoms. Okay. Atom X has mass number 40, atomic number 20. It combines with another atom Y whose mass number is 35, atomic number is 17. Write down its chemical formula. If both of them are going to combine, in what ratio they are going to combine, what is their chemical formula is what you are going to find. Okay. I'll show you how it is done. First atom is X. X having mass number 40, atomic number 20. And second atom is Y having mass number 35, atomic number 17. This is atomic number, means number of protons are 20, number of electrons are 20, number of neutrons are the difference between these two, that's also 20. For this, protons are 17, electrons are 17, neutrons are the difference between these two, that's 18. Now write down their electronic configuration. To write the electronic configuration, look at the electrons. So electronic configuration for the first one, 20 is the number of electrons. So K shell has 2, L has 8, then M has 8, 8 plus 8 is 16 plus 2 more. Okay. That will give you 18. And this 20. So N has 12. So 2, 8, 8, 2. Add it together, that gives you 20 electrons. Let's write the electronic configuration for this. K shell has, there are 17 altogether. K shell has 2, L has 8, M has 7. 2, 8, 7 together is 17. Okay. Now, have they achieved stable electronic configuration is what you have to see. Look at the last orbit. Is it fully filled? If it has to be fully filled, this must be 8. But it's not fully filled, it has 2 electrons. So either it has to give away the 2 electrons to attain stable electronic configuration, or to make this 8, it should get 6 electrons. So giving away 2 electrons is easier, or getting 6 electrons is easier, is what you have to see. Giving away 2 electrons is easier. So if it gives away 2 electrons, okay, X becomes X2, it gave away 2 electrons, means gave away 2 negative charge. Therefore, this will become 2 plus. It gave away negative charge, therefore this becomes positively charged. Let's go to this. Let's see whether this is fully filled. Last orbit is this. If it has to be fully filled, this has to be 8. Okay, but it's 7. So it either has to get 1 electron or give away 7 electrons. Getting 1 electron is easier compared to giving away 7 electrons. So it gets 1 electron. Okay. So if it gets 1 electron, then this becomes 8. It is getting 1 electron, means it is getting 1 negative charge. Therefore, this is going to become negative. So Y gets 1 electron, so it becomes minus 1. 1 negative charge it got, so it is charged minus 1. Okay. So that's about X and Y. Now, how do you get the chemical formula when they combine? Is, look at this. X is a cation with 2 positive charge, and Y is an anion with 1 negative charge. They have to combine together. Okay. So this is actually their valencies. Whatever you got is their valency. X having valency 2, Y having valency 1. This we have seen before, even in the first chapter, how to get the chemical formula. X has valency 2, Y has valency 1. Now comes the crisscross method. The 2 goes with the Y and the 1 goes with the X. The 1 comes here, that is X 1, no need, right? And Y gets the 2, so Y 2. So if X and Y combine together, it will combine and form a compound like this. 1 atom of X and there should be 2 atoms of Y. So the chemical formula is XY2. So with this, I have given you some homework. We have already done 7 questions before this. So in continuation to that, this is question 8 up to 17. This is how you will number them in your copies. Question 8 is from page 62. Under 1988, you will do question 1. Next, page 62, under 1989, you will do question 1. In page 63, under 1990, you will do question 3. Page 63, 1991, you will do question 1, and so on. About the last one, question 17, is from page 65. You will do unit test paper question number 1, 4, 5, and 6.